Smart-1. Smart-1 was a Swedish-designed European Space Agency satellite that orbited around the Moon. It was launched on September 27, 2003 at 23:14 UTC from the Guiana Space Centre in Kourou, French Guiana. Smart-1 stands for Small Missions for Advanced Research in Technology 1. On September 3, 2006, Smart-1 was deliberately crashed into the Moon's surface, ending its mission. Smart-1 was about 1 meter across, and lightweight in comparison to other probes. Its launch mass was 367 kg or 809 pounds, of which 287 kg was non-propellant. It was propelled by a solar-powered Hall effect thruster using xenon propellant, of which there was 82 kg at launch. The thrusters used an electrostatic field to ionize the xenon and accelerate the ions to a high speed. This ion engine setup achieved a specific impulse of 16.1 kns/kg, more than 3 times the maximum for chemical rockets. Therefore, 1 kg of propellant produced a delta V of about 45 m/s. The electric propulsion subsystem had a weight of 29 kg with a peak power consumption of 1,200 watts. Smart-1 is the first in the program of ESA's Small Missions for Advanced Research and Technology. The solar arrays made 1,190 W available for powering the thruster, giving a nominal thrust of 68 mn, hence an acceleration of 0.2 mm/s superscript 2 or 0.7 m/s per hour. As with all ion engine-powered craft, orbital maneuvers were not carried out in short bursts but very gradually. The particular trajectory taken by Smart-1 to the Moon required thrusting for about 1/3 to 1/2 of every orbit. When spiraling away from the Earth, thrusting was done on the perigee part of the orbit. At the end of the mission, the thruster had demonstrated the following capability. As part of the European Space Agency's strategy to build very inexpensive and relatively small spaceships, the total cost of Smart-1 was a relatively small €110 million. Smart-1 was designed and developed by the Swedish Space Corporation on behalf of ESA. Assembly of the spacecraft was carried out by Saab Space in Linköping. Tests of the spacecraft were directed by Swedish Space Corporation and executed by Saab Space. The project manager at ESA was Giuseppe Racca and the project manager at the Swedish Space Corporation was Peter Rothsman. The principal project scientist was Bernard Foying. The Advanced Moon Microimager experiment was a miniature color camera for lunar imaging. The CCD camera with 3 filters of 750, 900, and 950 nm was able to take images with an average pixel resolution of 80 m. The camera weighed 2.1 kg and had a power consumption of 9 watts. The demonstration of a compact X-ray spectrometer was an X-ray telescope for the identification of chemical elements on the lunar surface. It detected the X-ray fluorescence of crystal compounds created through the interaction of the electron shell with the solar wind particles to measure the abundance of the 3 main components, magnesium, silicon, and aluminium. The detection of iron, calcium, and titanium depended on the solar activity. The detection range for X-rays was 0.5 to 10 keV. The spectrometer and XSM together weighed 5.2 kg and had a power consumption of 18 watts. The X-ray solar monitor studied the solar variability to complement DCIXS measurements. The Smart-1 infrared spectrometer was an infrared spectrometer for the identification of mineral spectra of olivine and pyroxene. It detected wavelengths from 0.93 to 2.4 m with 256 channels. The package weighed 2.3 kg and had a power consumption of 4.1 watts. The electric propulsion diagnostic package was to acquire data on the new propulsion system on Smart-1. The package weighed 0.8 kg and had a power consumption of 1.8 watts. The spacecraft potential, electron and dust experiment. The experiment weighed 0.8 kg and had a power consumption of 1.8 watts. Its function was to measure the properties and density of the plasma around the spacecraft, either as a Langmuir probe or as an electric field probe. SPAD observed the emission of the spacecraft's ion engine and the wake the Moon leaves to the solar wind. Unlike most other instruments that have to be shut down to prevent damage, SPAD could keep measuring inside radiation belts and in solar storms, such as the Halloween solar storms, 2003. It was built by Finnish Meteorological Institute and its name was intentionally chosen so that its acronym is the same as the nickname of SPAD Pasanen, famous Finnish movie actor, movie producer, and inventor. The algorithms developed for SPAD were later used in the ESA Landerfully Ka-Ban TTNC experiment. The experiment weighed 6.2 kg and had a power consumption of 26 watts. SMART 1 was launched September 27, 2003 together with INSAT-3 and eBird 1, by an Ariane 5 rocket from the Guiana Space Centre in French Guiana. After 42 minutes it was released into a geostationary transfer orbit of 7,035 × 42,223 km. From there it used its solar electric primary propulsion to gradually spiral out during 13 months. The orbit can be seen up to October 26, 2004 at spaceref.com, when the orbit was 179,718 × 305,214 km. On that date, after the 289th engine pulse, the SEP had accumulated a total on time of nearly 3,648 hours out of a total flight time of 8,000 hours, hence a little less than half of its total mission. It consumed about 58.8 kg of xenon and produced a delta V of 2,737 m/s. It was powered on again on November 15 for a planned burn of 4.5 days to enter fully into lunar orbit. It took until February 2005 using the electric thruster to decelerate into the final orbit 300 to 3,000 km above the Moon's surface. The end of mission performance demonstrated by the propulsion system is stated above. After its last perigee on November 2, on November 11, 2004 it passed through the L1 Lagrangian point and into the area dominated by the Moon's gravitational influence, and at 1748 UT on November 15 passed the first periselene of its lunar orbit. The osculating orbit on that date was 6,704 × 53,208 km, with an orbital period of 129 hours, although the actual orbit was accomplished in only 89 hours. This illustrates the significant impact that the engine burns have on the orbit and marks the meaning of the osculating orbit, which is the orbit that would be traveled by the spacecraft if at that instant all perturbations, including thrust, would cease. ESA announced on February 15, 2005, the endorsement of a proposal to extend the mission of SMART 1 by 1 year until August 2006. This date was later shifted to September 3, 2006, to enable scientific observations from Earth. SMART 1 impacted the Moon's surface as planned, on September 3, 2006 at 5 hours 42 minutes and 22 seconds UTC, ending its mission. Moving at approximately 2,000 m/s, SMART 1 created an impact visible with ground telescopes from Earth. It is hoped that not only will this provide some data simulating a meteor impact, but also that it might expose materials in the ground, like water ice, to spectroscopic analysis. ESA originally estimated that impact occurred at 34 degrees 24 minutes south 46 degree 12 W/34.4 degree S 46.2 degree W/-34.4, -46.2. In 2017, the impact site was identified from Lunar Reconnaissance Orbiter data at 34 degree 1543 S 46 degree 1135 W/34.262 degree S 46.193 degree W/-34.262, -46.193. At the time of impact, the Moon was visible in North and South America, and places in the Pacific Ocean, but not Europe, Africa, or Western Asia. This project has generated data and know-how that will be used for other missions, such as the ESA's BPI Colombo mission to Mercury.